Hi everyone, in this video we are going to be doing a complete observability project on Kubernetes using AI, OpenTelemetry and Honeycomb. So observability is a hot topic lately. Every other week there's a major app outage caused due to slow request, API failures or random 500. And that's when entire internet freaks out on Twitter. Why? Because modern systems are too complex to debug manually. If you have ever debugged a distributed system, you know the pain. There are too many dashboards, too many metrics, too many logs and too little time. And that's exactly why I am making this video. In this project, we will be building a full observability environment using Kubernetes, OpenTelemetry, Honeycomb and Honeycomb MCP Server. Then I will show you how you can literally ask your AI assistant, why is my service slow? And it will pull telemetry data from Honeycomb and give it to you. This is future of debugging. Let's get into it. Alright, so I'm here on my computer screen, and before I type any command, let me tell you everything that we are going to do in this observability project. We start by creating a local Kubernetes cluster using Minikube. Then on this Minikube cluster, we are going to be deploying OpenTelemetry demo application. Next, we also need a Honeycomb account. So if you don't have an account, go create it. The link is in description. Once we have our Honeycomb account created, we will route all the telemetry data. So all the metrics, logs, traces from this OpenTelemetry application is going to be routed to Honeycomb account. After that, we are going to be integrating the Honeycomb MCP server in VS Code. So instead of going through the logs and dashboards inside Honeycomb account, we can simply ask the MCP server. And for that, we need to first authenticate using OAuth. So you need to confirm your username and password of your Honeycomb account. And finally, we will debug our system using natural language. So let's get started. All right. So the first step is to create a Kubernetes cluster in my local machine using Minikube. Since this OpenTelemetry demo application has too many microservices in it, for example, accounting service, ad service, card service, checkout, email, frontend, and so many more, we need to make sure that our Kubernetes cluster has enough resources. So I'm going to say Minikube start and also provide CPUs equals to 6, memory equals to 12228 and disk size as 40. Now, when I run this command, it will start creating a Kubernetes cluster. Till the time this is going to be created, let's go and create our Honeycomb account. So go to honeycomb.io. Honeycomb is a very popular modern observability platform used to debug distributed application, and it is also used by companies like Duolingo, Intercom, Slack, Vanguard and lot more. I already have my account. If you want to create an account, click on this start for free button or also check out the link in the video description. So when you click on this, enter your details and this is the page you will see after you have your account created. Now on this side you can see environments. Right now I have a single environment with the name new. I'm going to be creating a new environment for this particular demo and click on this create environment button. Let's name this as Otel demo. If you want, you can also describe your environment. I'm going to leave this empty and let's click on create environment. Now this is the page you will see when you have an environment and your account ready. We are going to be using the API key from here. So let's keep this tab open and then come back later on in some time. Now here we have a Minikube cluster created. You can also confirm by running Minikube status command and you should see the same output as me, which is control plane running, host running, everything configured. To run this application, we need to also have kubectl installed. If you don't have kubectl installed, go and get it. If I do kubectl get pods, it will show me no resources found since this is a new cluster. Before we go ahead, to make things easier for you and to make sure that you complete this project, I have a Notion document created with all the commands and every step to follow to complete this project with me and also showcase it on LinkedIn. So if you want me to share that document with you, comment below AI observability in the comment section. Now that we have our cluster created, we are ready to deploy this OpenTelemetry demo application and we are deploying this on Kubernetes. So I'm going to select this setting here. We are deploying this application using Helm. So I'm going to run the command helm repo add OpenTelemetry this chart. Since we want all this telemetry data like logs, metric, traces in Honeycomb, we are not going to be using this command directly. We will instead use Honeycomb configuration. And if you go to OpenTelemetry demo application on GitHub, you can see this demo application can be used by different observability platforms and you can see Grafana, etc. Here we are going to be using Honeycomb. So this is the repository. If we want to use Honeycomb and pass all the telemetry data to Honeycomb, we need to provide our own configuration. And for that, I have a file already created, which is values.yaml. You can see this is the configuration data. And here I also need to pass my API key. I'm using my own API key and I will show you how things work here. But if you want this configuration, it's already present in the Notion document. And if you want me to share that Notion document as PDF, comment below AI observability. For now, I'm going to open this project in my VS Code. So this is my VS Code. and this is the configuration here. You need to change your API key to your own API key from the Honeycomb account. So I'm going to go to Honeycomb account, and then in the Honeycomb account, you can see the API key here. So let's copy this API key. So now I have my own API key. After you have this configuration, we are going to then run the Helm install command to install the OpenTelemetry application using this configuration. So the command is Helm upgrade install the name of the application. This is the path, and I'm saying use my file, which is values.yaml. Let's press enter. All right. We don't have a namespace. Obviously, we need to first create a namespace that in which we are going to be creating. So I'm saying kubectl create ns Otel demo. So now the namespace is created. Let's rerun the command, and this time it will go ahead and install the OpenTelemetry application. If you get the same output as me, where you can see this Otel demo, which means it's running, and this application is available on the path localhost 8080. It also has a Jaeger endpoint at this particular path. Jaeger is a very popular tool for tracing. Then you have Grafana dashboards at localhost 8080/Grafana. Then there's load generator, feature flags, etc. Right now, as you can see, the application is still in container creating state. The pods are still being created. And if you want to access this application, you need to run this command kubectl namespace Otel demo port forward, and then the application will be available on localhost 8080. So if I run this command right now, I will get an error saying the pod is still in pending state. So we need to wait for 3 to 4 minutes before this pod comes up. And if you go to your Honeycomb account, right now there's no data here because the application is not running. Honeycomb can be used with Node.js application, with Python application, Java application, .NET, Ruby, etc. etc. We are running this on Kubernetes, and that's why we are using a values.yaml file. You can also use environment variables if you want to get the telemetry data transported to Honeycomb. For now, let's wait till all the pod comes up. Okay, finally all the pods are now running, and you can also see the application is up on localhost 8080. This is the OpenTelemetry demo application, which is an astronomy shop. You can go ahead and play with it. Along with this, you can also access Jaeger, which is a tracing tool on Jaeger/UI. Since we are going to be routing all the telemetry data from here to Honeycomb, you can see now Honeycomb also has some data here. So we have traces coming in, incoming spans, and lot more. Spend some time in this Honeycomb dashboard, go through all the traces. So we have different services here. This is for load generation. You can see traces here. You can also see logs coming in. And if you want to query, you can go to this query tab and check out different slow requests, what are the errors, and a lot more. Now, for someone who does not understand how this actually works or how to check traces, logs, etc., we can use Honeycomb MCP. Using Honeycomb MCP, you can simply ask questions like show me all the different slow requests or tell me about where the latency is low, rather than wasting your time through this dashboard. Think about it. You normally debug by opening up Honeycomb, then clicking on queries, selecting a data set, filter by service, filter by error type, and a lot more. So rather than this, we can simply use Honeycomb MCP. And to use it, click on the account section here, go to my account, and here you can see MCP or Model Context Protocol. I already have it. I'm going to revoke it and show you so I can show you from scratch. So copy this server URL and go to your VS Code. You can do this either in VS Code or in Claude, Cursor, anything. So I'm going to click on this and click on show and run command, add server, HTTP, and paste the URL that you just copied. Click on enter. You can give this a name. So I'm going to name this as Honeycomb and press enter. Let's make it global. And this is my MCP server configuration. Once you add your MCP server, it will ask you to authenticate. So click on allow, click on open button here, and this will open up the browser. Now here I'm going to select my team and then select permissions, click on read and write, and then authorize it. This is how you will add your Honeycomb MCP server. Click on open Visual Studio Code again. Now I can go ahead and ask questions. So I'm going to choose this agent option, and you can see tools. In the tool section, if I scroll down, I can find Honeycomb here. These are all the different tools that Honeycomb MCP server is able to do. So it can create a new flexible board with fixed grid. It can submit feedback about Honeycomb's MCP server. You can find relevant columns across datasets, find relevant queries, get datasets, and a lot more. Let me show you an example. In this Honeycomb account, you can see we have different services like load generator, Otel demo, payment, quote, etc. We also get the logs and traces for every service here. If you are an expert, you will obviously understand what's going on here, going through the graphs. But instead of going through the graphs and wasting our time, we can either use the query here. So you can click on query, and then you can also see slow request, what are my errors, latency distribution, a lot more. But here the output is again in the form of graph. To make things more easy, we can use the Honeycomb MCP server. Let me show you an example. So I'm going to ask, list all the datasets in my Honeycomb project. And now Honeycomb MCP server is working. It will give us the list of all the datasets present inside Honeycomb server. So you can see the output here. It gave us all the datasets present inside Honeycomb project, and these are all the different environments. That's amazing. Let's try to run a query now. So I'm going to ask it to run a query to find 10 slowest endpoints in last 30 minutes. If you were to do this in the Honeycomb dashboard, you have to go through the query and then find out the 10 slowest one. But here you can simply ask a question to your LLM and it will give you the output right here. This makes observability so easy. So you can see the 10 slowest endpoint are all these 10 one here. So we have /API/checkout, which takes around 83.77 milliseconds and so on. Can you give me which service has handled the most requests in last hour? So it says the service that handled most requests is the front-end service with about 12,161 requests. That's crazy. Let's try with some more examples. Let's ask, which is the slowest endpoint in last 15 minutes? So the slowest endpoints in last 15 minutes are API checkout. Again, we got this. Also, if you want to go deeper, like for example, let's retrieve the trace for the single slowest request in last 30 minutes and show me the full trace details like trace ID, spans, timeouts, etc. This is amazing. It gave me the complete information about the trace ID, which is the slowest single endpoint, and it also gave me all this information like span ID, timestamp. If I were to do this in the console, it will take me so much time, but along with this information, it also gave me a link where I can go and check this trace details in Honeycomb. Honeycomb MCP gives you result in natural language answer along with a link to the dashboard. So it makes observability very, very easy. Make sure you try out Honeycomb MCP for yourself. To do that, you need to create an account and the link is in description. Also, if you want a step-by-step document for this project, comment below AI Observability and I will see you in the next video. Bye.